Hello again, and welcome to Radio Free HPC. This is where we talk about supercomputing, high-performance computing, and other technology topics. I'm your Toastmaster, Rich Bruckner from Inside HPC, with my co-hosts, Dan Olds from Gabriel Consulting, and Henry Newman from Instrumental. Now let's get to the show.
Hooray!
Well, welcome back, guys. This is Radio Free HPC. I'm Rich Bruckner, and today we have Dan Olds, of course, and Henry Newman as my co-hosts. But we have a special guest today.
Quit, Rich, first of all.
Well, I quit what?
Quit saying Henry and Dan Olds like it's a surprise to you. We've done about 30 of these things, and every time it's us three. So it's like today we have Dan Olds and Henry Newman. You always have Dan Olds and Henry Newman, or actually we have you.
Yeah.
Yeah, you with me on that, Henry?
I hate to agree with you, but I do.
Okay. I'm sorry, Rich. Go ahead. And we also have a guest today. Rich, go ahead and get on with your oh-so-professional introduction.
All right, guys. Welcome back to Radio Free HPC. Of course, we have, as always, Dan Olds and Henry Newman here with Rich Bruckner, your Toastmaster. But today we have a special guest from Univa. We have Fritz Ferstl. He is the CTO of the company. And Fritz, welcome to the show today.
Hey, Rich. Thanks for having me. Also to Dan and Henry.
Nice to meet you, Fritz.
Nice to meet you too, Dan.
Henry, say hi to Fritz.
Hi, Fritz.
Okay.
Fritz and I have
Henry.
known each other for a long, long time, Dan.
Yes, that is true.
You're still talking to each other, though, right?
More than a decade. Yes, we are still talking.
Then you could say hi to him here just to help us get the ball rolling and make him feel at home and comfortable. That'd be great.
Just seeing my shining face would make Fritz home and comfortable.
Absolutely.
Okay, I'm going to let that go.
And, and Fritz and I know each other as well for a long time from Sun Microsystems and the Grid Engine days. But I thought we'd have Fritz, as a guest, kind of present to us a little bit with this idea about big data and HPC and the convergence and what's going on there. And I think he's got a very unique perspective to share with us. So why don't you take it from there, Fritz?
Yeah, so I've actually brought a few slides, just a handful, to help us guide the discussion a little bit. I'm not sure we can keep the structure, but we can at least try, right?
Oh yeah, this is all about structure.
This show? Oh yeah.
So the topic that I've proposed is we discuss about whether HPC and big data need to embrace or extend, or rather whether HPC needs to embrace big data and extend it. And that's also the title of the slide. So on slide number 2, we have the agenda. So one is introductions, which I believe we have completed.
I'm going to put a big check mark there.
Yeah. So then we can talk about whether big data is really another form of HPC, whether there are differences, commonalities, and synergies. We can also look at whether there is maybe an advantage in using a more concise terminology in talking about those terms. That might help because big data, quite frankly, has been a pretty broad term, whereas HPC is sometimes a little bit of a narrow term, so maybe some more concise terminology might help.
Well, Fritz, why don't you first define what you mean by big data before we even talk about this? What is your definition of big data?
Yeah, scale-out analytics in very short terms. So basically data analytics that benefit from actually scaling them out on a cluster. So processing more, processing it quicker.
So not just Hadoop, but also taking in, let's see, deep data mining, visualization.
How about graph, Fritz?
Yeah, absolutely. I mean,
graph analysis?
Yeah, absolutely. This all belongs in that pile. What I don't see that much in that pile is, for instance, like some people do, is just rebranding if they have been crunching on massive amounts of data per se, right? I mean, that as such doesn't define big data. I mean, there has to be a way of new analytics or something like that in it. Yeah, and in terms of HPC, actually, the term that I prefer more is high-capacity computing, right? Because there is not just the one big parallel application. There's also throughput processing and similar things.
And there's also scheduling the I/O, because if it's big data, you've got a huge amount of storage and I/O requirements. correct?
Oh yeah, absolutely, absolutely.
Sure.
And so along those lines, we can also look into whether, for instance, HPC can help big data to make faster progress and to be more effective. And on the other end, I mean, there is certainly innovation in the big data space, and can that maybe help in some corners of HPC to augment the HPC space. And finally, we can look at some major gaps and focus areas that the industry should be looking at in order to, improve life for everybody.
Well, let's jump right into this then. I see a graph.
Yeah.
One of these fancy, like a half magic quadrant thing. Okay.
Yeah, exactly. So, I mean, I actually was struggling for quite some time with how I would depict this, and I would not claim this is complete or perfect or anything like that. But you can arguably draw a graph where you say, okay, what's really common between big data and HPC and what is different. Then there is different values of synergy, certainly if you look at individual items. So if you look at some examples here on this graph, then let's say a server node architecture. I mean, they are probably largely common between big data and HPC,
Sure.
but there is certainly more emphasis on I/O, at least for some applications in big data, maybe more emphasis on the memory, less emphasis on the number crunching on the particular node. But there's enough commonality and certainly synergy potential in that area.
But Fritz, I got a question. Wouldn't you agree that in certain cases, or in a lot of big data, you don't need floating point? I mean, when you're doing a lot of the correlation and things like that, you're using a different part of the CPU.
Exactly. That's why I say, I mean, they are not totally identical, right? But there is, commonality. I mean, there is applications where the server nodes would actually look pretty much the same, and there is cases where that's not quite the case. I've also recently seen somebody actually developing a non-MySQL database which actually uses GPUs. So this is also something that seems to be possible, right?
That's a burgeoning thing. There was at the recently concluded GTC, there was quite a bit of big data type stuff.
Yeah.
When you have virtualization on the common side, do you mean that's because both HPC and big data aren't using it much?
Exactly.
Okay, good. Because I do think that when you get big data in the enterprise, it's going to end up being a virtualized workload. I think it has to be.
Yeah.
So I think that'll change.
Although I would submit that if you, let's say, move to a architecture where a node doesn't cost as much anymore, let's say if you had an ARM-based architecture for like throughput computing types of things, then the cost of virtualization may not be worth spending, right?
So in other words, that type of node would make it more of an appliance type of system?
Yeah, very much so.
Well, but Fritz, when you get an ARM system, the bigger cost won't be the CPU, it's still going to be the memory. And you don't think that the memory costs are going to justify it?
Well, I mean, what does virtualization help you in terms of the memory?
Higher utilization?
Potentially.
Well, if you're doing it right.
It depends on the application, I guess, right? I mean, if you actually don't use the memory with one application that runs on a node, yes. If not, then you're basically using the node in full, so you don't have a point to use virtualization at all.
It depends. You're talking about scale out. It's being able to use infrastructure you already have to be able to scale out more instances and have them share nodes and things like that, because a lot of enterprise nodes are going to be 4-socket, larger capacity systems. That was one of the big promises of the grid in my mind, was for these kinds of workloads to be able to, from an enterprise perspective, use all the infrastructure you have opportunistically.
Fritz, on your chart, I'm curious as to why you put file systems to the left of accounting. Why are file systems so different?
Yeah, so first of all, on that chart, there would be areas which are awfully crowded, right? So they would basically fall into the same spot, and that's why I said the chart is probably not perfect. So I had to put them somewhere to not overlap.
A font choice then.
Why is there so much difference in the file system requirements and usage for big data compared to HPC, I guess would be my question.
Yeah, I mean, lots of big data applications, specifically in the Hadoop world, use a different file system, right? They use HDFS, and HPC doesn't use HDFS. It could. And also, Hadoop can be using distributed file system from the HPC space, but the reality is that's not the established standard.
But there seems to be a movement in discussion about using parallel file systems and Hadoop on top of parallel file systems, and people have shown some significant benefit from doing that for certain problems. Obviously, not everything. So I was just curious: do you see that file system part staying there? Or do you see it moving to the right?
I see it moving to the right. That's also why there's the synergy potential relatively high, right? I mean, the one area where probably HDFS has a big advantage is simply in the failover scenarios or in the high availability scenarios. That's not necessarily as well built in distributed file system in the HPC space. And that's also, if you need in the HPC space some functionality like that, you might be benefiting actually even from using HDFS for some of those applications.
But HDFS only runs on a per node basis. There's no sharing. So there's limitations, significant limitations with HDFS.
Oh yeah.
Compared to what we're used to in the HPC world.
That's why I say it's really for specific applications, right? I mean, you have to be very picky about that, whether it gives you an advantage or not. There's no question about that.
I have a question on data model. What do you mean by that term?
Data model, I mean, exactly what we were just discussing, right? I mean, in HPC, I mean, you usually have your data partitioned, and you usually have a very exact view on where data resides. So you have determined communication patterns and stuff like that. And that's not the case in the big data world. That's why this is pretty much to the left lower. Right? I mean, I can see applications in the HPC space where that's not so much the case.
I would say from the enterprise side of it, most of them are pretty aware of where their data is and have planned out where it is and all the issues surrounding that. I think they'd have to.
In general data application, enterprise data application space, yes. In unstructured data scenarios, not so much.
In the Hadoop world, that sort of thing, yeah, maybe so, but that's not the bulk of what enterprises are doing in big data. I think that they're doing a lot more of modeling, visualization, deep data mining, that sort of thing. Although the Hadoop gets all the publicity and there's some very large customers doing it, the bulk of enterprises I don't think are quite there yet.
Hadoop doesn't work so well on video analytics, for example, and pattern matching, facial recognition, looking for specific items.
I'm not in disagreement there.
Good stuff. Rich, any questions?
Well, I've never seen this charted with these particular dimensions. I really like the idea of raising up the common things in terms of their synergy potential, not necessarily where they are today, but what offers us some opportunities. And of course, Fritz, you come from the workload resource management. I just wonder if you could comment on that. I mean, you're already touching both worlds now, right?
Yeah, that's true. So we have an integration with Hadoop in particular. And what we see in the Hadoop world is that there is very limited workload and resource management capability. And even the newer versions of Hadoop, which have something like Yarn, yet another resource. I never know what the N means, right? But it's yet another resource something.
Yeah. And
also some other tools, like for instance Mesos. I mean, if you look at them as an example, Mesos has some 20,000 lines of code, right? Grid Engine has some 2 million lines of code, and that's not just because we're filling in code because we don't know what else to do. That stuff is in there for a good reason and has grown over 15 years or so. So, the functionality which is currently provided in terms of things like, policy management or access control, quotas, all the things that, let's say, an HPC customer is very accustomed to, is just not available in a Hadoop ecosystem. And so there's a good potential for things like workload management, but also for accounting, reporting, or in the system management space, to have some HPC best practices, the corresponding software environment benefiting a big data and Hadoop ecosystem.
So, Rich and Dan, I've got a couple questions for Fritz. I mean, I've been hearing a lot from a lot of places of people wanting to do an overall accounting for users and applications, and that might include everything from, the factory floor, as I call it, with big data, as which could be a graph problem, it could be NoSQL, it could be video analytics, it could be Hadoop. Are you looking at how you would account for this sort of production line in big data analytics?
So anything that Univa Grid Engine handles in terms of a workload, you can appropriately account for. And as of today, we can account for all the HPC workloads that we manage, but also for Hadoop workloads. So as soon as you get that integrated into Univa Grid Engine, you have the global accounting for all of these workloads. And
where do you think it's going to go for things like, NoSQL and even SQL calls? I mean, do you see the future as a combined accounting framework for all of this, or is that not possible?
Yeah, the question there is probably the granularity to which you want to break this down. I mean, if it comes to looking at how much is being spent on a NoSQL data processing as such, then that's certainly accountable. I mean, that would be doable. If you go down to a per transaction level, you need to do this a little bit differently. You need to get information for that out of the NoSQL system.
So it'd have to come from the application.
Yeah, then combine it with the rest of the accounting system, I would think.
This is something, this workload and resource management, I think that's absolutely vital for big data in the enterprise. And again, not just Hadoop, everything else that customers are really doing, because this is going to enable them to be able to use systems that they have. It works hand in hand with virtualization, I think, in order to make this efficient and doable, so that enterprises don't need to buy essentially a dedicated HPC-like system in order to get into this.
Right.
Well, and they also need it for resource planning for future requirements.
Absolutely.
Yeah.
Absolutely. And to be able to see what's coming up.
Yeah, so that's what we have seen with our customer base using that integration. I mean, basically, they have been starting with POCs on the Hadoop side. And once they wanted to go in production, they were basically saying, okay, am I now supposed to buy a siloed cluster for that particular application? And when they go to the CIO says, wait a minute, you have a cluster over there, right?
We don't buy silos anymore.
Right. So, I mean, the whole cloud space has taught us, and the whole virtualization space has told us how to share. So we're not going to go back in time. So you guys need to figure out how you share. And that's why they have approached us and why we have done that integration.
Great. Let's move on.
Yep.
And
so
we're talking nomenclature now.
I think we have actually talked about this a little bit already. So, my proposal would be to be a little bit more precise and talk about scale-out analytics versus just the very broad and unclear term of big data. And then again, instead of HPC, which lots of people take as being just one big parallel job that is run somewhere in a big lab, calling that high-capacity computing because, it's capacity along all dimensions, be that, as Henry said, on the data side, on the file system side, on the compute side, and also, throughput versus just crunching the numbers. So I prefer that type of nomenclature. And if you do that, then I would say, scale-out analytics is kind of the enterprise IT part of high-capacity computing, and I would be interested what you guys think about that.
My thoughts on this is sort of a layman and coming at this with the technology background of a 10-year-old boy and not the smartest one. My looking at this and looking at big data analytics for the last few years is that there's a lot more commonality between enterprise analytics and HPC than there are differences. That a lot of the models, the computational models and the stresses that those are going to put on infrastructures, essentially they're running the same kind of routines. It's just different data, and they're asking different questions of different data, and there's a time constraint.
But if
Henry, feel free to rip that apart.
I'm on it, Dan. If you look at it from the infrastructure point of view, I would tend to agree with some of what you said on the memory bandwidth requirements, on the computational requirements. I still think we're using different parts of in some cases, the CPU. When you get into the I/O side, we're not doing checkpoint restart. We're doing something different. And we're not necessarily doing the kinds of streaming I/O that are doing with checkpoint restart environments with end-to-one, end-to-end. We might be doing end-to-one kind of I/O. We might be doing some small block random. Depending on the kind of analytics. You're doing video analytics, then you are doing end-to-end, but it's read-oriented, not write-oriented.
Good point.
I think infrastructurally some of it's the same, but I enjoyed being able to rip you up a little bit, Dan.
But I would maybe insert here that maybe on some of these enterprise analytics workloads, we should be doing things like checkpoint restart.
Depends.
That's something, yeah, you're right. It depends on the workload and what you're trying to get out of it, but that is something I think is going to come into enterprise.
But some of these might be self-checkpointing by, I've gotten to this point in the job. I mean, some of the applications are different, and we need to think about them in different ways and how they work. You might not need to dump memory. You might just need to look at the output file.
Good point.
I mean, video analytics might be a good example of that.
Yeah.
Fortunately for me, doing workload management, I don't care about these things. I don't have to care about those things. I can handle them. Whether there is a slight difference, I just need to get the job to the right nodes and make sure the right resources are available, and that I can do.
In talking to enterprise customers, do they realize that there's a big need here, that this is something they're not going to get out of VMware or KVM or something like that?
Well, some do, right? And the other guys are a little bit in the POC phase. I mean, it's still really early. You have to say that, right?
Well, I think this brings up an important point, guys, because I was talking to Steve Conway about this from IDC, and he's kind of their point person on this big data where it meets HPC. And a lot of people in this space that we might look at their setup and say, oh, that's HPC or that's not. They don't identify with that word at all. No. And the term he gave me that he likes to use for this place is called a high-performance data analysis. And it is what it says it is, right? I mean, the high-performance part is, yes, that they are doing that. But the minute we say HPC, their stigma, the connotation they're thinking of is simulation for nuclear weapons and car crashes and crash test dummies, this kind of thing, and they don't identify with that. So I think Fritz is bringing an important point out here with this nomenclature.
And it's interesting where I think there's a lot of commonality is that so much of what is done in both worlds is like multivariate regression. And that has huge applications all over, trying to figure out what cause is causing what effect and how much each cause plays a role in that. And that's something where they are very, very close. And but you talk to enterprises and they don't see themselves doing scientific computing at all.
Right. Yeah.
I like your suggestions here.
Sounds good. Let's move on. One more thing, which is looking into embracing and extending. So who embraces who and who extend what? I would submit that HPC actually can help big data to get fast forwarded. I mean, if I just look at the workload and resource management part, if, let's say, for instance, just focusing on Hadoop, if they keep working on refining the resource management stuff, they'll probably take another 5 to 10 years until they are where we are right now. So why would they not benefit from HPC in that space? And pretty much the same is true in system and infrastructure management. right? Also, in terms of programming those things, I mean, Hadoop is Java, right? And Java performance. While you can get performance out of Java, is it the most natural language to do this? Is it the most natural paradigm also to do debugging and all those things on the development side? File systems, we talked about that already, right? I mean, definitely lots of these big data applications can benefit from actually using an HPC distributed file system. Will give them immediate improvement. And then also the whole aspect of managing a system in such a way that it is, a well-governed, controlled, well-accounted for system, that you can use kind of as a shared environment is another area where I think they can benefit largely.
And yeah, because Hadoop has tremendous gaps in the security area, right? They don't even have roles-based kinds of things. So once you get that root access, you've got the keys to the kingdom. And we've talked about that before on this show.
Yeah. So actually, in our integration, every user gets his own Hadoop, right? So they don't step on each other.
Yeah.
Something I think that would really ring clear and resonate with your enterprise customers is to be able to talk about this almost in the way that a mainframe works, in that they're going to be able to, with tools like this, get business policies into the software to ensure that the important critical applications hit their time requirements. Without operator intervention.
Dan, I agree with that. And the key, though, is getting the infrastructure in the operating system to allow those business policies and allow the control mechanisms. So, Fritz, we've done over the last 10, 15 years, done a pretty good job in Linux putting the framework in so you can control things in HPC. Where are we at with Hadoop? Is it there in the operating system so you can control Hadoop workloads, or there need to be things added?
No, actually, so the mechanisms in Linux are sufficient. I mean, specifically now with C groups also, this is something, where you basically can contain the workload pretty much completely. And I don't see really there's any need to work on the Linux side.
Yeah.
That's good news.
It's a great thing, and I remember talking about this when I was doing a lot of work in virtualization at Sun, and dreaming and hoping for something like this to come along. We just didn't have it. It was too soon in the mid to late 90s. But it's this grid-like capability, this grid capability, really brings the open systems, x86 systems, into that world where they can truly be manageable like a mainframe.
Right. Mm-hmm. I agree.
So you're saying at Sun you were waiting for x86 to come along, Dan?
I was waiting. I was waiting for those geniuses that did Solaris to go ahead and make a make versus buy decision and go ahead and buy the capabilities that we needed, because they weren't ever going to get around to making them, as it turns out.
Okay. Yeah. Just finishing up with the other side of the coin here, which is can big data actually augment HPC? I would think that for some application scenarios, as here in the bottom, it's actually possible to use HDFS, but really for some restricted application areas. The data analytics application integration might actually help. There's lots of HPC applications which definitely require data analytics at the back end. And if technology is developed in the big data space that improves that, why not utilize it? Why trying to develop your own? And then also on the data model side, as I mentioned, some applications may have actually difficulty due to the rigid data segmentation that you have in HPC environments. And the way how MapReduce functions makes some applications easier to program, I believe. So MapReduce can be a paradigm that also HPC applications can use in a few restricted cases. That's the only things that I could come up with.
Fritz, what are some examples? Because I don't see them. So I'm curious of what your examples are.
For MapReduce?
MapReduce and HPC.
If I look what MapReduce algorithms actually do, I don't know why you can't find in the classical HPC space applications that are easier to program with MapReduce versus classical message passing.
I think I might have one. Did you guys read about that huge large array telescope that's going in, I believe, in Australia?
Yeah.
And they have some sort of just insane amount of data coming off of that, streaming off every minute or so. I mean, just truly insane. I want to say terabytes a minute and petabytes an hour, something like, but it's very large, large enough that they can't store it. And I wonder if MapReduce type routines might help them decide what data to keep.
Possible, yeah.
Henry?
I mean,
you know what? I don't know enough about the data, but it sounds like it's a comparison. It'll be, possibly. I don't know.
I just can tell you from, we have a couple of customers in the high energy physics community, and I've been visiting a bunch of them, and almost all of them do have a Hadoop POC, so I guess they have them for a reason. I'm not to comment, whether that's a promising POC or not, but, at least they are looking into it.
At least checking it out.
Yeah, at this point, yes.
Well, one thing I would add to this, Fritz, just from a business standpoint, will big data augment HPC? I think one thing they are doing very well is creating ecosystems for growth and expansion. If you look at something like Hortonworks, they have this platform where basically you take Hadoop as a basis, but they're saying, come and create apps for this, and we'll go take this into the business world. And almost if you think of like the iTunes model, right? You had everything soup to nuts. You had the device to play it. You had the distribution method for the songs. And once all that came together, suddenly they changed the music industry. So I see that as something that's going on in the big data world where we in the HPC should watch and learn. Do you guys agree? Or?
Yeah.
That's an interesting proposition. I mean,
Maybe.
The other thing, since you're mentioning business, I mean, the other thing that certainly big data does, it makes a, let's say, CFO understand why something like a cluster is necessary.
Yeah. True.
Yeah.
Fritz, be nice.
Well, no. I think right, because he can see a business case, right? He said, "Oh, we got all this data, and I can turn this into insight that helps me make money." That's a much easier case than simulating CFD,
we shouldn't be prejudiced against the people who have limited technical understanding.
Yeah. Yeah,
like
Rich.
dance.
Rich,
You're such a bigot.
Yeah. Exactly.
I hate to see that kind of bigotry.
I was thinking exactly the same thing.
About Rich being a bigot?
No.
Oh.
So Fritz, I looked at your slide number 7. I assume in slide 7, the green is the potential synergies that can be moving from left to right. Is that correct?
So yeah, that would be, areas where you could focus attention, where there's probably the biggest bang for the buck if you're trying to create synergy. So things where the synergy potential is high, but you're not yet to the right of things are common. So I mean, again, you can always debate about what's in it and what's out of it, but that's the general idea.
Is this intentional that you have GPUs mostly shaded, but phi not shaded, and not the S in GPUs? So is it just a single GPU? Yeah.
Car uses... No.
Because actually,
No.
I think that probably the whole thing probably should be shaded, because I think accelerators are catching on in enterprise, or will be catching on in enterprise reasonably soon.
Yeah, no, I've just, resized this a couple of times, and that's where I left it alone. So don't interpret this too much.
But you see accelerators as something that will be coming in on both sides?
Well, I mean, first of all, as Henry has been pointing out, integer arithmetics is something that is beneficial to the data analytics world in particular, and GPUs can do that reasonably well. So that's certainly an area, yeah, for sure.
Good.
And also this NoSQL database that we've been talking about. I mean, if you can really accelerate a distributed database, then my former employer might be sweating a little bit, being Oracle, I mean.
Well, Fritz, thank you for taking the time to spend with us. It was an interesting discussion, and hopefully you could come back in 6 or 8 months.
Yeah, let us keep us up on what's going on. Sure. This is good stuff.
Absolutely.
Yeah,
you should at least hear or see from us in the media, and I will definitely reach out to you guys.
Yes, you won't hear or see from us in the media, but we'll hear and see you. So that's good. At least somebody will be hearing about somebody. We really appreciate your time, though. Thank you very much.
Well, thanks for having me, guys.
And that's it for this episode of Radio Free HPC. Everybody say goodbye.
Bye, everyone.
Bye.
There you go. Nice and polite. That's how we like to finish these things up. And we'll see you again on our next episode. Thanks a lot.
That's it for this edition of Radio Free HPC. Thank you for listening, and be sure to check back often for new episodes. Also, check out our website for more content, links, and a place for you to let us know what you think about the show. We're at radiofreehpc.com. Thanks again. We'll be back with another exciting episode real soon.